Okay, now, as we are going into the deeper understanding of trigonometry, not only you need to get the values, I would say it's also very important that you know if your values are correct or not. And I don't want you to just, like, yes, we are going to use a calculator. But how are you going to know, or is there any way you can tell that whether you are getting a correct answer or not? Now, for example, we are about to go to, we are about to put this into a calculator. We are about to, but don't do it yet. Don't do it yet. We're going to do something really quickly. So you look at sine 250 degrees. So if I ask you, where is this angle? Is this angle, which quadrant is this angle in? Quadrant 3. So right next to it, you can write down quadrant 3. And you think about this, sine of an angle that's in quadrant 3. Sine of an angle that's in quadrant 3. So the resulting ratio, should it be positive or negative? Well, how do we tell? Remember, this is the tool to help us out to tell which quadrant, which trig function will be positive in which quadrant. So we are looking at an angle that's in the quadrant 3. So therefore, sine of this angle must yield a ratio that is negative. So when you put into a calculator now you can go ahead and put in a calculator. Okay. And by the way, when you put into a calculator, make sure you check your right upper corner. Is it in degree mode? Okay. If it's not in degree mode, make sure you know how to change it. So the way you change it is to press the dock button, and then when you press the dock button, you can see, I believe you would get number 7 for number 7 for the setting, yeah, 7 setting and status, and then go to number 2. Which is the document setting, and then you can go ahead and change between the radians and degrees. And since we are in degrees, make sure it is in degree mode. So you should see DEG at your right upper corner. So what do you find for sine of 250 degrees? Oh, I mean, sine of 250 degrees. Negative 0.9. Now 3 decimal places, so it'll be 940. So if you round it, the 9 becomes a 0, so 940. So that's at least something to check your values. You're like, oh, yeah, I am anticipating a value that's negative, and the calculator is giving you a value that's negative. Then you have a better understanding and you're not surprised. So look at this. Tangent of negative 95 degrees. So what quadrant is this angle? Quadrant. Also quadrant 3. You go backward for a little bit more than 90 degrees. So that goes into the quadrant 3 territory. And is it positive or negative? That should be positive because it's tangent. So you can go ahead and do tangent of negative 95. And that will be 11.430. Now, I want you to do something. Let's just say you were so busy and you somehow forgot to type negative. Go ahead, type it in. Type in tangent 95 degrees and see what you get. Tangent 95 degrees, what do you get? You can see a negative value. And this is what I mean by having some way to check your answer. You know this is a quadrant 3 angle. It has to be positive. If for some reason you forgot to type a negative, and your calculator tells you that, hey, you have a negative ratio, and you'd be like, wait, hold on. Something just doesn't add up. I am looking for a positive value. Why is the calculator giving me a negative value? Okay. All right, so now just a few, you can go ahead and do the following. So cosine of 36 degrees, 50 minutes and 25 seconds, positive or negative? So first, if this is in quadrant 1, right? 36 degrees. So cosine of an angle in quadrant 1 must be positive. If you look at this one, 239, it's in quadrant 3 again. So tangent of an angle that's in quadrant 3, it's positive. So so we have positive for the remaining ones. Now, the reason why you see this, okay, just in case if you wonder, like, why do you see this? Now, in the old calculator, like this one, like a TI 84, 83, the old calculators, they do not have secant, cosecant, or cotangent. So in order to compute these cotangent, cosecant functions, we will have to do the reciprocal manually. But now with the Anspire calculator, if you press the trig function, you have all these functions ready for you. So you would not need to do something like this. You would not need to do something like this. You can just type it in cotangent of 239, and you get the value straight away. Okay. So so go ahead, take a moment. Go ahead, find out what that is. Cosine of 36 degrees, 50 minutes, and 25 seconds. You should get a number that is 0.800. Yes? Okay. Cotangent of 239. Do you get 0.601? Okay. And then you have cosecant. You get 1.668 as your ratio. Okay, very good. Any question? Now, this is easy, but I want to make a point. I want to make a point right here. Okay, I want to make a point right here. So could you go ahead and write this in the empty space to the right? Oh, and by the way, the paper that you used for the unit circle, we will use it in a moment, so don't put it away. So when we have a trig function, this is a function. We'll say sine of something. What is this something? Okay, what is this something? And this is always going to be the angle. Okay, when you do trig function, it's always trig function of an angle, and that results in the ratio of sides. Whatever sides that we have to do with the trig function. If it's a sine function, then the ratio is going to be opposite over hypotenuse. So what I want you to see over here is this. Like for example, when we say tangent of negative 95 degrees, it's 11.43. That means the ratio of opposite over adjacent, okay, it is 11.43 to 1. That's a ratio. If you say, oh, cosine of this angle is 0.800, that means this 0.800 means what? It's the ratio of adjacent over hypotenuse. Okay. Now, if you don't pay attention to the nature and the meaning of these numbers, there will be a problem. There will be a big problem. So I just want to make sure that you know when you write down some numbers, you know what they mean, you know what they are. Do not just write down some numbers. Know what they are. Okay, now go ahead, try the following. Change the mode to radians and find out what is sine of pi over 8. Go ahead, change the radian. Again, click this document button and go to number 7, which is the document setting, I believe. Setting and status. Settings and status, and then you go to document settings, and then you can change your mode from degree to radian. Make sure you press enter to change your default setting. So you have sine of pi over 8. Do you get 0.383? Okay. What is this? What's the meaning of this number? Yeah, this is the ratio of opposite over hypotenuse. Okay. Now, the more annotation you do at this point, it really helps you build your foundation. Okay, and go ahead, finish the next one. Secant of 5 pi over 7. Secant of 5 pi over 7. Secant of 5 pi over 7. It is. Does it make sense to have a negative? Does it make sense to have a negative number? Why does it make sense? It's in quadrant 2 and it's cosine, right? Okay, so it's in quadrant 2, it's cosine. So again, you do not just write down whatever numbers that the calculator tells you. You have to be very careful. Okay. All right, now that's so the thing that I would like to emphasize here is that just make sure that you are very careful with the interpretation of these numbers. You can tell whether it's positive or negative. Now, on the back page of the unit circle paper you just did earlier, I want to draw some pictures. Now, you're going to make 6 graphs indicating 6 angles. So I'm going to show you one by one. Okay. So for the first angle, I want you to draw a 30-degree angle. Now, I will tell you what the reference angle is for each case. I will tell you what the reference angle is for each case. But I will not tell you what reference angle is at the moment. I will see if you could figure out what reference angle is. Okay, and just do a rough sketch. It doesn't have to be perfectly accurate. So just draw something that's right here, and you can call it a 30-degree angle. As long as you can see it, that's already very good. So what is the reference angle here? We say that the reference angle here is 30 degrees. The reference angle here is 30 degrees. And then the next angle you would draw, it's 150 degrees. 150 degrees. Anyone want to guess the reference angle? 30, it's correct. The next angle you would draw is 240 degrees. 240. What is the reference angle for the 240-degree angle? 60 degrees is correct. And then next one, 280-degree angle. Go ahead, draw the 280-degree angle. What's the reference angle? Now see if we can figure out how we actually measure the reference angle. So the last 2 angles that you would draw, 330 and 350. 330 degrees and 350 degrees. What is the reference angle for the 330 degrees? It will be 30 degrees. And the reference angle for the 350-degree angle is 10 degrees. So now the question is, how do we measure this thing called the unit circle? How do we measure it? How come it's 30? How come it's 80? How come it's 60 over there? Okay. Now let's look at this one first. 150 degrees, a 150-degree angle right here. Well, where is it the 30-degree angle? Where is the 30-degree angle? It is. It's right here. Now, if you have a highlighter or if you have a different color pen, that would be very helpful. So when we talk about reference angle, first, I really want the reason I draw you a picture is because if you don't have a picture, it is going to be difficult. It is going to be extremely difficult to identify the actual angle. So when we measure reference angle, it's always going to be from the x-axis. And that's why this is 30 degrees. So if you were puzzled earlier, I would say it makes perfect sense because when I learned it the very first time, I was very puzzled. So where is this? Where is this 60-degree reference angle? From the x-axis to the terminal side. That's 60 degrees. Okay, that is 60 degrees. We will never ever measure the reference angle from y-axis. It's always from the x-axis. So therefore, for this one, some of you may be thinking about 10 degrees for the reference angle. We say, no, it is 80 degrees. Okay, because it's 80 degrees away from 360 degrees. You always measure the angle between the terminal side and the x-axis. That's how you measure the reference angle. Okay. For this one, the 30-degree angle will be from the x-axis to the terminal side. That is the 30-degree angle. And this is the 10-degree angle. Question? Very good. Okay. Now, if you're good, why on earth are we doing this? Well, now we get the on the previous on the first page of the notes we got the ratio, right? So now, what if I ask you to write down this? Sine theta is equal to 1/2. So now we are trying to think backward. If sine theta is equal to 1/2, what's the theta? Okay. Now I would tell you one hint. Your unit circle may be able to help you out. If you know your unit circle, that may be able to help you out. Sine theta, it's 1/2. So we're asking, hey guys, what's the angle? What's the angle that gives you 1/2 for sine? Anybody? Say again? 30 degrees. So we say, hey, I know something. I know that if you do 30 degrees, it's 1/2 for the y value. So we say, yeah, so 30 degrees, it's one of the theta. But is that the only one? Well, how do you know it's not the only one? Well, yeah, we use the reference angle, and also we look at this one. The fact that the ratio is positive tells us something about theta. This theta could be in quadrant 1 and quadrant 2. So therefore, the other angle is going to be 150. Look at your unit circle. Look at 150 degrees. Can you see the y value? What's the y value? for 150 degrees? 1/2, right? So that's how we know. That's how we know. Now, what if I ask you this? If I ask you cosine of theta, it's equal to -1/2. Okay, cosine of theta is -1/2. So this theta must be in quadrant what? Quadrant 2 and quadrant 3. Because cosine is positive in quadrant 1 and quadrant 4. So if it's negative, that implies it is in quadrant 2 and quadrant 3. So now, so what we say is this. Let's just look at 1/2 first. Okay, we say, cosine of what is equal to 1/2? Cosine of what angle is equal to 1/2? We say a cosine of 60 degrees. It's 1/2. You can look at your unit circle. Look at the x value. So 60 degrees, x value. That's 1/2, right? But now this is just a reference angle. We know our angle must be in quadrant 2 and quadrant 3. So our two angles would be. Actually, hold on. Let me draw the picture first. It's better to have a picture. So that means we have to have 180 minus 60 degrees to give you 120. That's the angle in quadrant 2. And the angle in quadrant 3, it's going to be 180 plus 60, which is 240 degrees. If you don't draw pictures, it's going to be hard for you to decide whether you are doing 180 minus or 180 plus. Or do you use 180 or do you use 360? But once you draw the picture out, it's extremely clear. Okay. Now let's go ahead, turn to the back page of the notes. Okay. So, and we'll do some practice together as well. Now, the back page of your notes, it sets cosine theta in degrees. Okay. It's a 0.9266. So, first, what's the meaning of this number again? It's a ratio of what side over what side? Adjacent over hypotenuse. Okay. So so we get the ratio. It's a 0.9266. It's a positive number. So that means we can conclude theta must be in quadrant 1 and quadrant 4. Okay, again, if you are not asking question, but you don't know how you get these quadrants, it's a positive value. So that means it must be in quadrant 1 and quadrant 4. Okay, if you say how do you get the quadrants, this is because of this. So when you put into your calculator, so if you put into a calculator, now what you would do is this. You have cosine theta of 0.9266, right? If you want to get theta by itself, that means you need to cancel out the cosine. How do you cancel out the cosine? Well, just like how we did the stuff before, right? If you want to cancel out log, you need to do the inverse, right? Don't use the word opposite, use the inverse. So, so here, that's what we do. So after you use the inverse, you get theta by itself. So that's why you put this into your calculator. So you do cosine inverse of the ratio. And this would give you a number that is 22 degrees, but that is not your final answer yet, because that's only a reference angle. Well, we know that it is in quadrant 1 and quadrant 4. So this will be the angle in quadrant 1, but what's the angle in quadrant 4? Well, in quadrant 4, so this is going to be 22.0891 degrees. So to get the value from the beginning to the end right here, it's going to be 360 minus the 22 degrees. All right. Now, any question at this point about how we get 337.9? Okay, because we know it's in quadrant 4. So we say, all right, 360 minus the reference angle. Now, if you look at part B, you look at this number. Sine theta, it happens to be negative. So what does it tell us? What does the negative tell us? Quadrant 4 and quadrant 3. So we say, oh yeah, it's in quadrant 4, quadrant 3, and quadrant 4. Now, so that is the job of the negative. Yeah. And when we try to find the reference angle, you can ditch the negative and just find the reference angle. Okay. So we find the reference angle, which is an angle that's between 0 and 90. So you get 37 degrees, 37.5823 degrees. And that's your reference angle. And since you know it is in quadrant 3 and quadrant 4, well, if you draw the picture, quadrant 3, and quadrant 4, how do you get this angle? You do 180 plus, right? I hope that's common sense. And how do you find this angle? How do you find this angle right here? What would you do? $360 minus. Okay. Now, and that's why I said you have to draw pictures, especially at this beginning stage. If you don't draw pictures, it's going to be confusing. And when I was a kid, I was learning this, and I was like, when do we do 180 minus? When do we do 180 plus? Things were kind of confusing. But once you draw a picture, you know what it means when you say, oh, the angle is in quadrant 3 or the angle is in quadrant 4. Then the whole addition and subtraction thing, extremely straightforward. Okay, now let's go ahead and try number 14 on your worksheet. Just try number 14. So Tangent, it's negative. Tangent, it's negative. So that means that theta must be in quadrant 2 and quadrant 4. Okay, so that's the information delivered by the negative sign. And then we say, all right, so what's the angle? So the reference angle, it's going to be, you would type in tangent inverse of the ratio, tangent inverse of the ratio, and we are using degrees. So degrees. So tangent inverse of the ratio, you get 15.104 degrees. But since it is in quadrant 2, and quadrant 4, so what's the actual angle? So we have right here 164.896 degrees. And then you have from here to here, that is 344.896 degrees. Okay. For the now the back page would be a good practice to get you ready for the quiz on Wednesday. The materials here would not be covered on the quiz, but the back page material will be on the quiz.